In this video, we'll be going over path sum 2. Given the roots of a binary tree and an integer target sum, return all root to leaf paths where each path sum equals target sum. A leaf is a node with no children. So in our first example, we're given this tree, and then we're trying to find all possible root to leaf paths where the target sum is 22. So we have found two paths where 5, 4, 11, 2 is equal to 22, have a sum of 22, and our other path is 5, 8, 4, 5, which also have a target sum of 22. Let's go over the thought process. We will be implementing a recursive backtracking approach. We will need to keep track of our current node values in the path and also the sum of the node values. Then when we reach a leaf node where both of the children are node, we can check if our current sum is equal to the target sum. If sum is equal to the target sum, we will add the current path to the resulting list. After we finish visiting one path, we want to go into a different path. After we finish one path, we can backtrack our steps by removing the last added node value into our current path in our current path. This will allow us to take on a different path. Let's go over to code, to pseudocode. So we're going to implement a recursive backtracking approach. And then, before that, we're going to create a list results to keep track of all paths that has a sum of target sum. Then what parameters do we need? We need the node, the current node we are visiting, and also path, the current path, and also our sum, the current sum, and also our target sum is the input target sum, and also the resulting list of all paths. And then what's the base case? If the current node is null, this means there are no more value here. We can just return from the recursive call. Because we will only want to visit the nodes from root to leaf, then in each of the recursive call, we're going to add node.val to sum. Then we want to check if we're currently at the leaf node or not. If node.left is null and node.right is null, and the current sum is equal to the target sum, this means we have found a valid path with a sum of target sum. So we're going to add a copy of path to results because it is by reference. So that's why we add a copy instead of just passing it right in. Now we want to recursively traverse to a left subtree. Node.left. And then we want to recursively traverse to right subtree. Now after we finish both subtrees, we want to backtrack our steps to find another path. So we're going to remove the last elements from path. After we finish our recursive calls, we can return our results, which hold all of the paths that has a sum of target sum. Let's go over the time and space complexity. For time complexity is of n, where n is the length of the input array. Of n, we visit each node once. And our space complexity of 2 times h, where h is the height of the tree. This is because of the recursive call stack memory and our path list. We are not going to account for the resulting list in this example. Let's go over the code. So we'll first create our list result to keep track of all paths. Return result here, and then we're going to implement our recursive backtracking approach the roots, and then we check our parameters. We need a path. It's the current path, the current sum, and the target sum, and also the resulting list. The current node we are visiting, and this is the current path, the current sum, the target sum, and the resulting list. If node is equal to node, there's no value here, we can just return from the recursive call. Then we want to increment sum by node.val. Now we want to check if we have found a valid path. Oh, there's one more thing we need to do is to add the current node to path. So I'm going to add node to path, or node.val to path. So path.add node.val. Now we want to check if we have reached a leaf node, and also check if the current sum is equal to target sum. So if node.left is equal to null and node.right is equal to null, we have reached a leaf node. And then we have to check and sum is equal to target sum. That means we have found a valid path. Then we can add the current path to our resulting list, a copy. Now we want to recursively traverse to the left and right subtrees. Traverse the right subtree, and then we want to backtrack our steps by removing the last added value to our path. Let me know if any questions in the comment section below.